Hello everybody. I was just wanting to kind of give a tour of Lean AI and how Lean AI works. First of all though, let me double check that the stream's actually working. Okay, good. Always worried about camera arrangement. YouTube. Sorry about the feedback. Am I actually working here? Test, test, test. Okay. Alright, cool. Looks like everything is working. Had to verify via the laptop here. So the intention of Lean AI, if you haven't caught any of the previous streams or any of the previous videos on Lean AI, it's a harness that I built for what am I doing? I got too many windows open. Jesus Christ. It's a harness I built for being able to work with local AI agents. Now, you can still work with Claude Code, Codex. Those all still work. The purpose of this project is twofold. If you're using this as an individual and you can't afford another subscription because Netflix, Amazon, Hulu, Disney, HBO, car insurance, every other silly fee that we have to all pay every single month just to live, this is potentially an option if you have a computer sitting around with the GPU that maybe you use for gaming, but maybe you also have an idea for a business. You're not a programmer, you don't know how to write code, you don't know what to look for. The purpose of this system is to break down that barrier as much as possible. By that I mean you start by opening VS Code. I know that might seem slightly intimidating. I mean, it's free, you can download it. I think if you can install any kind of application on Windows, you shouldn't have any issues. Open up VS Code, then you can go into the extensions manager and then simply search for Lean AI. Once you find it, then all you have to do is install it. Obviously, I already have it installed. Once the extension is installed, then you can work with it through the sidebar, view appearance, secondary sidebar. Oh, it's there. I've just because my dual monitors. Can I find it? There it is. Okay. Oh, I had it. Maybe. Might be overdoing it by using the AI at the same time as trying to stream. I might be. There we go. Okay. So once you have the extension installed, it automatically pulls in the backend services as a part of the extension. That's just for easier install and setup. And then if you'd like to change anything, then the only other requirement is that you install Ollama. Ollama has a very straightforward install process. There are a lot of YouTube videos online about how to install Ollama. And then you just need to download a model. You do not have to use every feature of this application. The primary thing you need to do is set up this primary coding agent and have Ollama running, and then pick a model. And then there are tutorials online about using Ollama pull and then pulling the LLM that you'd like to use. This works on Windows, this works on Mac, this works on Linux, which is why I kind of standardize it on Ollama. Llama CPP works on everything as well. There's more setup involved though, depending on what video card you have for Llama CPP. So just the easier entry to barrier, or easier way to access this is just through Ollama, and to make this system work easier. So then once you've picked a model, which in my case using a myriad of experts, the Quinn 3.6 35B model for the primary model. The primary model is used in a couple of ways. If you just have the primary model, it does everything. If you are okay with a slower process that is going to provide better results, I recommend having a secondary model. That secondary model is your expert model, and in this case I would recommend a dense model. I am using a Quinn 3.6 27B. And the reason I'm using a dense model here is so when you're using a mixture of experts, one caveat to have is it is much faster. It is easier to manage hardware wise, and is less resource hungry, I guess, to a certain extent. So you're going to get more tokens per second, so it's going to seem like more work's getting done. Downside is it's like hiring a developer that has ADD. The problem is they know what they're doing, but they get distracted very easily. So if you come over and you interrupt them in the middle of trying to work, all bets are off on whether or not they're going to remember where they were, or if they have to start over and try to figure out what in the world they were in the middle of doing. So MOE experts, our models, are good for speed, and they do a reasonably good job, but you really need a dense model to review collected information from an MOE and then provide a structured plan, because it can actually analyze, keep attention, and review all of the data that's come in and been collected by the MOE model. And then it can actually synthesize a plan without missing as many steps as an MOE would. I'm not going to justify or say that any of these models are going to be perfect. However, that's the reason why I use a expert model. I always recommend a dense model. You should use the largest size you can. I'm always using quantized versions 4. If you really want to get into this, you can. You don't have to know all of that. You could just download the normal model or just do an Ollama pull for the base model. It's always going to be quant 4. You don't have to think about that. If you're just a normal user, just download the standard model that's suggested by Ollama. You'll get the exact same thing. Then set your context size. I recommend not going less than 64K in your context window. If you can do 128, do it. If you can do 256 because you have enough graphics card memory, do it. In my case, I do not. I am running, as you can see here, I have two GPUs. I have the AMD Radeon RX 6800 with 16 gigs of video RAM, and then I have the oops, I clicked on the wrong one. I was like, I'm confused. AMD Radeon RX 6700, which has 12 gigs of RAM. So between the two, I have 28 gigs of VRAM. And if the important thing here is you want your offload to be as little as possible. So right now I have 9% of my, which model am I running? Oh, Quinn 3.627B, sorry, Jesus. So of the 27B model, I have 9% running on CPU, 91% on GPU. Now, in a perfect world, I would reduce my context window a little bit, which would allow me to run this 100% on GPU. However, I've found that when you're at that 64K context window, the model more frequently has to do a compression of the chat and storing it into the journal feature of the application, so that then when the context refresh happens, it knows where it left off. And that whole process just takes time. And the system's already slow, so that little bit of overflow onto my actual VRAM, in my opinion, is worth it due to the fact that the amount of time saved by having the larger context window versus the amount of time lost from having a smaller window is ultimately levels out. And then you don't have to worry about the LLM getting confused about where it left off. Maybe it forgot to summarize something that was important. So it's just more of a safety net. So once you have Ollama set up and you have a primary model set, you can set the context size, the temperature, and most of these settings will be, can be found online. If you don't know how to set these settings, you can just use the base model. You can leave all of this as 0, and other than the context window, make sure you set that yourself. Then let Ollama choose the settings. Ollama has default settings for all of these local LLMs, so if you're not sure what to choose, just let Ollama use its defaults. Because every model's different. For best results, I would recommend doing a Google search for these settings for whatever model you choose, and it will give you the best settings for coding agent. Then reasoning effort. So this isn't actually controlling the ability for the LLM to think. What this is actually doing is it's curtailing the model whenever it's in the thinking phase. So whenever it's producing a thought, if for some reason it gets stuck or it's just looping and repeating itself, there are some tools in here to nudge it to write itself. Also, worst case scenario is having reasoning effort set will nudge it again and say, hey, you've exceeded the number of tokens you should have used in any stretch of the imagination to think through this process. So you need to produce a result at this point, right? Which again is another nudge from the back-end system that's saying, hey, get back on track. You've gone off the rails. Let's get you back on track, right? So that is what this setting is for. So if you have a very small context window, if you're doing 32K or 64K, if you're doing 32K, I recommend going with the medium reasoning effort. If you're going with the 32K context window, you're definitely going to want to go with the low reasoning effort, again, this is not a setting that's actually controlling how hard the model thinks about some, or how well the model is able to interpret the task. This is managing how many tokens the model can produce during its thinking process before the backend script starts polling the agent saying, hey, I think you've lost the plot. You just keep thinking about this process and you're not taking any action. Let's actually produce something. Either respond to the user, call a tool. You need to do something. You can't just sit here and think for the next 30 minutes. It's not what we pay you for, even though we're not paying it, right? Depending on the model you choose, something you will notice when you are on Ollama's website. And let's do... Okay. How do I... Back to the scene, and that's annoying. Sorry, everyone. I don't have a third monitor. Alright, so for Qwen 3.6, you'll notice that on some of these models it has text and image. So based on this text and image setting, so text is just the ability to do the chat and the ability to work basically in an agentic workflow. Especially with my system, as long as it can interact with text and it can produce a structured response, then it will work with this system. The image is another nice to have. The benefit of the image system is that it then allows you to paste images into the chat. So when you paste images into the text box as you're chatting with the LLM, it can then analyze that image, especially when you're dealing with generating a website and you're like, oh, you know, that search box isn't supposed to be in the top left corner, it's supposed to be in the bottom right, or it's supposed to be in the bottom center, or whatever, right? So then you can take a screenshot, post that into the chat, explain what's wrong with the image. Once it analyzes the image and has an understanding of what's in the image, then coupled with your request, it can formulate a plan of, oh, okay, I see what you're saying. You know, yeah, that is in the top left quadrant. So it actually breaks the image into a 9-segment quadrant. So then it's actually able to understand a UI from a human's perspective, or from a visual perspective, more than it would if you just provided it an image and said, that's in the top left corner, I need it in the bottom right or the middle center or whatever. It's going to be confused. It's going to be like, I see a search bar. You know, when I reviewed the image, I didn't note it. I didn't note where the search bar was. I just noted that there's a UI element search bar. It didn't care in the image where the item was. So the system automatically makes it break it down into a quadrant system so that it can actually understand user feedback about images with UI requirements that need to be updated. So once you get these settings, then you can do supports image, and you can check that box. Once you check that box, then now image ability is now provided to your LLM, so now it can actually analyze those images. The expert model is used just to condense a plan and make a more coherent plan, and the request model. So the request model, and I'm going to scroll up through here. I went ahead and went through and generated an entire plan. The request model is the model that you're going to interact with to formulate a plan. So in this case, so in this case, first thing that happens when you open VS Code and you're in a project directory, it's going to automatically figure out what project you're in, and that could be based on the project context or whatever. If it's a brand new project, you can use the scaffolding tools that are a part of Lean AI. And you can, with the scaffolding tools, you can specify what type of project it is, the name of the project, and what kind of code base you're going to be working with. And if you need more help, you can always ask the LLM about what these tools do, and it will be able to explain what each of these / commands are, regardless of what project you're in. And it can offer some more input, and it can even provide examples of how to use these tools. Once you create a new project, you'll always want to run the init command, which will build the project context so that the model will understand what you're working on. Once those two things are done, or 3 steps are done, right? First, you download the extension, you set up Ollama, then your next step is, or you could even set up Ollama first, then download the extension. It doesn't really matter what order you do it in. If you do it in the wrong order, the only problem you're going to get is you'll see an error message down here in the output terminal window for VS Code. It'll start saying Ollama not available, backend can't communicate. It's not hurting anything. Don't panic. Just close the application, get Ollama installed, get a model installed. Then through the extension, then once you relaunch VS Code, then you can go into your settings and set up your model. Okay, so we were discussing the request model. So the request model, its primary role is communication back and forth with you. So the reason I kind of have this as a separate model is since we're ideating or thinking through a problem or a task that we would like to accomplish, the benefit here is that we can set the temperature high, right? We're not actually doing any kind of code edits. We're not expecting the model to produce any code. We want to allow the model to be as creative as possible with its responses. We want the responses to be coherent. However, we're not concerned with it being perfectly accurate with every token it produces, right? Because it's not working with variables, it's not trying to produce a structured JSON response, it's literally communicating with us, just like you would with ChatGPT. It does have to read through and understand what the current project's doing, which is provided by the project context and its ability to read through the files. So in this case, a very simple thing here that I could have done with the fix command, but I'm just using it as an example. I asked the model, and in this case I'm using Gemma 426B A4B Q4, and the reason I'm using this model with 128 context window is because this model does fit within my VRAM, meaning that it doesn't have that overflow of 9% onto CPU. It's 100% GPU, meaning it's going to run as fast as it possibly can. And the restriction is the speed of the VRAM on my GPU and the processing power of my GPUs. So its only limiting factor is my GPU. And generally it's producing about 50 tokens a second, which is perfectly fine. It's a respectable speed for especially just having a quick conversation and some simple tool calls. And Gemma does a fantastic job of getting tool calls right and having conversations. I don't necessarily... It can make code edits. It's not super reliable on its ability to think through what it's been asked to make the code edits. It seems to deviate from the initial request, and it starts trying to do its own planning session and its own like testing and everything. Like it's been trained in a way that when you give it a straightforward task of, I need you to edit this file and update this one line of code, even though you have been completely explicit in what you want it to do and do nothing else, and it's been clearly defined. I think because of the way it was trained, Gemma immediately says, oh wait, no. I need to read the file, see what all that file touches, what other files rely on that file, and then maybe I can come back and do your edit. But I'm not just going to do an edit. Like, I want no part of that, right? And because of that, even though an entire review process has occurred, it gets wild. It just starts trying to edit a bunch of other things that it's not supposed to edit. It's just not reliable in a harness. I'm assuming that, Google probably planned on people just using this directly with their own MCP server with a few tools, and didn't want to rely on anyone actually building a harness. They just wanted to structurally have it semi-complete to decide to call tools on its own, which isn't a bad thing, but the downside is I don't think models can be reliably, especially smaller models, can be reliably leaned on to always make the most logical conclusions and edits and review of code bases without a harness. Maybe a small code base, maybe a small website. Otherwise, it just gets out of control really quickly. The model just doesn't have enough information, and the context windows aren't large enough. So I don't know what Google was thinking when they decided to code Gemma that way, or fine-tune Gemma that way, but it's the way they did it. However, it is beneficial to us when we are using it in request mode, because we do want to use its ability to go out and find all of those edge cases and all of those files that are interconnected with our request. So in this case, just asking it to go out and find all of the default entries for co-author within the Lean AI application that are currently set to Lean AI instead of Lean AI bot, because Lean AI apparently was taken on GitHub, which is interesting. It's my fault. I should have reserved it earlier. I didn't. But anyways, it goes through and it's looking for anywhere a file touches this default co-author. So then it goes through, it does some thinking, it looks at the project context, and responded with, after it did a single search, what it found. It found that within all of these files, there is a link to the default co-author listed as Lean AI, where it should be Lean AI -bot. So then it explains current understanding of what it found. Then it had a question if it should also update the documentation and unit test to reflect the change, or only the functional code. It gives a recommended answer. Again, the really beneficial thing to this harness, the whole point, is someone that is not familiar with coding but wants and can't afford, maybe there's some 14-year-old kid that really wants to get into AI, and he has a gaming computer his parents gave him for Christmas, and he loves to play video games, but he also kind of wants to learn about coding, and he wants to learn about AI, and he wants to learn how to interact with AI. The really cool thing is this application could work for him, especially if he's not super familiar, or she, he or she, I was the 14-year-old boy that wishes he had something cool like this. So forgive me. She, ladies, it could be a young lady that's interested in AI and coding and computers, right? But they're not sure how to get started. But they have a gaming computer and they love to game. Now they can repurpose or reuse that same computer when they want to and close it all down and still go back to gaming later. To actually start exploring and implementing and playing with code. And the great thing is, I learned, in my opinion, the great thing about AI, especially these systems for younger kids, is back in my day, we would, and this is Netscape Navigator days, we didn't have Firefox. We had IE, Netscape Navigator, and that's about it. So Netscape Navigator was the first browser I really used. I think maybe it was on floppy disk. And I don't even remember where I got it from. I think I got it from a bookstore with one of the coding manuals I bought. Yeah, it must have, or I might have got it on cassette when I bought my first physical copy of Linux, which I believe was a copy of Red Hat Linux. And yeah, it probably did come with the manual. And then I think it also came with it came with the CD for Linux, Red Hat, and then it also came with a cassette in case you had Windows for Netscape Navigator. I'm sure that was probably a throw-in to, maybe Red Hat got a little kickback or something that helped reduce the cost of shipping or something. I don't know. Anyways, it was really exciting to get Netscape. Then, in my day, sorry, back to our story. ADHD. Whew. Back to our story. The benefit when I was learning coding was you would view source on websites. And web coding then was way simpler. We didn't even have JavaScript when I first started. It was all HTML. I remember when it was all HTML and Perl. So I remember using Perl to generate static HTML pages based on the URL that was entered, and it was cool. It was like the first interaction I ever had with a website. And I believe I was learning that just from maybe using a website called WebMonkey or something. And then we didn't even have Google. It was Yahoo Directory, and there was an underlying Yahoo Directory service, because Yahoo Directory was built on top of another source that Yahoo bought, and I can't remember the name of it now. Anyways, disparate pieces of information was so hard to come by, right? Really cool thing is you can have a conversation with a chatbot that's definitely going to know more than 14-year-old me or whoever that's just now learning, right? Most 14, there are always exceptions to the rule. There's some 14-year-old out there right now that is probably 1,000 times smarter than me in coding. So if you're that kid, good for you, man. Guy or gal, you're doing awesome. That's cool. But the great thing is, coder or non-coder, someone who wants to explore, there's always going to be a recommended answer. There's going to be a question, recommended answer, and why it matters. If you're confused on the question, you can ask the LLM more questions to help clarify what it's trying to get you to understand. And then once you respond and ask, so in this case I told it that it should review the documentation and test and create a suggested agent prompt. You always want to work towards a suggested agent prompt. If you're working with a brand new code base, this is where it gets fantastic. If you're working with a brand new code base, and you ask it to generate a suggested agent prompt. Understand that you are about to enter the grill me mode. I did not invent grill me. I believe it was Matt, and I don't remember Matt's last name. One moment, let me pull that up. GitHub grill me skill Matt. Let's see if I can find it here, because I don't want to steal credit for this. I did not design this skill, but I integrated it into the application because I thought it was so fantastic, and there's no way I could have done it better. Matt Pocock is the creator of that skill, and you could visit his GitHub. I don't want to steal or suggest that I did anything with designing the grill me step, but it was such a fantastic skill, especially for this use case. It will start grilling you, trying to get the LLM to understand what you're requesting, and trying to get you to understand what the LLM is suggesting. So then the person and the LLM can come together and attempt to have a much more solid understanding of each other before any code implementation ever happens. So this grill me phase could be, and Matt Pocock has a bunch of videos on YouTube about this. It could be 40 questions that the LLM asks you. If you don't know the answers, obviously it's always going to suggest a answer based on the current code base. If it's an empty code base, there's going to be a significant number of questions. If you're unsure of how to answer those questions, you could even probably use the free ChatGPT. To help you understand what it's asking, because it could be simple questions that just not coming from a coding perspective, you don't know what it's really asking you, like using SQLite or maybe MySQL, or whether or not you should use a JSON format for storing some data or whatever. You can just head up a free tool like ChatGPT to just try to kind of understand it, or you can even just do a quick Google search, or again, you can have a back and forth with the LLM, like, I don't understand what that means, can you kind of help me understand what that is? And it will walk you through each of those small pieces, because those are things that the actual LLM understands. Where LLMs fall apart a bit is when you overwhelm them, or when you are not specific enough. So the whole idea of this harness is to find that alignment. Thank you, Matt Pocock, for creating the grill me skill. I think it's the most fantastic skill I've ever seen. I think it's probably the biggest gift to using LLMs that exist currently that I've found, other than the LLMs themselves and the geniuses who design them and have fine-tuned them ever before I got involved. Those people deserve the credit that is due as well. So once you find that alignment and all of the LLM's questions have been answered, in this case, it was able to arrive at an answer quite quickly. The grill me phase lasted one question. The reason it was only one question was due to the fact that this is a very mature code base with a very large code base, session history, memories. So for the LLM to answer those questions, the benefit is, as you build a project with your LLM, the number of questions you'll get from the grill me phase is going to be less and less and less, because there becomes a built-in understanding of what's supposed to happen. So if you use it from the very beginning of generating your project, you end up with a coherent understanding from the LLM and you, and the architecture that's needed for this project, and it becomes solidified. It makes it easier for the LLM to understand, it makes it easier for you to understand, and this understanding makes it easier for the LLM also to do its next token prediction based on all of that context it has. So then it was able to generate a suggested agent prompt, which looks very similar to a plan. This always requires references. It's basically a plan. The difference here is that this now presents you with a send to agent. The send to agent button, when you click that, automatically starts a planning phase. This planning phase goes through a 5-step planning process. And the reason I designed this way is when you're working with a local LLM, this again, harnessing the local LLM to do what it's best at, this is another step of trying to get the LLM to align with your request and your code base, and get those two to mesh for when it generates more code for the code base that has a very clear understanding of what exists, what you would like to exist, how to implement those two things. So the first thing is it goes through and it reviews the suggested agent prompt. It then says, okay, I know we already went through a grill me phase. It doesn't actually know that, but it sees the suggested agent prompt, it reviews that, it says, okay, are there any questions that I have about this? It did for some reason the first agent, which is going to be the request agent, which in this case is Gemma. This agent is now using, now we're in the primary agent territory, which is going to be Quinn 3.635b MOE for this step based on my setup. And it's saying, okay, now I just got this handoff of this suggested work. I need to make sure that I understand this. If I feel like anything is missing here, this is my opportunity to ask the user for clarification because something just doesn't seem right. Or maybe Gemma missed something, right? Or wasn't clear on something that Quinn is able to understand. So this is one less next step that gives the LLM another chance to question you about, oh, there's something fishy about this, or this is unclear, to harden its understanding of what you really want to have done. If it feels like that prompt is solid and it completely understands it, then it goes through and it generates a scoping document. That scoping document that's generated then is sent, it's produced in JSON. I think, is that produced in JSON or is that produced in Markdown? Let's find out together because I've done back and forth. So implement, no, plan debug, okay. All right, so phase one is produced as a Markdown file. So it produces a Markdown file that is then fed into phase 2. Phase 2 then begins the exploration of the code base. So I know we've already kind of done an exploration in the initial request prompt, and it did some quick searches, some quick grep, just to kind of get a quick understanding. It didn't do a whole lot of file reads. You know, that's not its intended purpose. It's not looking for exactly every edge case and everything. At the very beginning, it's just looking for a quick understanding of what you're asking and trying to get an alignment. It's not trying to look for edge cases and everything else. It's trying to actually have a conversation with you, try to get an understanding to create that suggested agent prompt, and then start moving through the next process. So phase 2 then is going to generate a markdown file. That markdown file, is this, hold on, maybe this is from an older one. Let's go to, so these files are not generally saved unless you have debug mode turned on in your settings. If you are using this system in a development environment in a company, I would recommend you keep these on. This is a really good logging feature to figure out why and resolve why LLM did what it did. Okay, so clarification phase, right? So this is the first step where the LLM received the suggested agent prompt and then tries to determine whether or not it has any questions. Phase 1A is producing the scoping documentation, which is going to get fed into Phase 2 for research. Phase 2 is going to produce a markdown file for file identification, which then will be able to be used in the following planning phases. The next one is the design and risks analysis, which is Phase 3. Phase 3 is going to look through the file observations that were recorded by Phase 2. Phase 2 is probably the second longest phase of all of the phases. Phase 3 is going to generate risks, documentation, notes, then gets passed into Phase 4. Phase 4 is going to take in the scoping documentation, the risk documentation from Phase 3, and the Phase 2 file summary to actually generate a plan. That plan is generated in two ways. It is generated as a markdown, and it is also generated as a JSON file. The markdown file plan is presented to the user. Not yet. Is then just saved as a... is that presented to the user? It's not presented to the user in a way of it used to be. I think I might have stopped that. So let's see here. TDD test steps, design 3 steps. Planning, design, and risk synthesis, that's step 3. Planning, plan assembly. Okay, no. It is no longer presented to the user. So this document used to be presented to the user because I added an extra phase, which is the test-driven development or just the testing phase, depending on what you have set in your settings. So Phase 5 will use that original Phase 4 plan markdown file with some additions that it makes for the verification step, the testing phase. So it reviews the plan and then designs tests that need to be implemented to actually validate that plan based on all of the code changes that were designed into the plan. The reason it goes through all these steps, which seem ridiculous, right? I mean, an AI should just be able to, like I was saying, Gemma kind of goes through its own process of this, right? But it's not very good. It's just not solid. It's subpar at best. The reason it goes through all of these steps is to encourage the end result because we're using local models, right? Oh, Jesus Christ. We're using local models, and they're not always the best at staying on task and keeping things performative, no. Reducing liability in your code, right? So all of these steps are just steps that a normal engineer or software developer would go through. I feel like these things weren't put in there, and these steps were not created by project managers, other engineers, businesses, for the simple fact of paperwork, These steps were put in place on purpose because issues happened. Things broke. People got woke up at 4 o'clock in the morning. People resolved to find solutions to these issues. So why don't we have the LLM follow the same process? Having the LLM follow the same process is going to improve the output of the code that the LLM produces. In this case, like I said, very simple thing that could have just been a fix, right? The plan's ready, it's ready to be approved. Scope, gathering around and spec target files to locate exact line numbers surrounding context and current string values for the GitHub, co-author name, default theme AI, record findings to prepare the subsequent editing round. Steps. It's going to read the file. All these files were identified earlier. Reason, establish baseline for the back end configuration default. Okay, read file with reason, read file. Affected files. Okay, that's strange. I don't see a single edit file. Strange. I don't see a single edit file command in the plan. No, we want to update that default AI co-author to AI bot. So this is where you could give it feedback to tell it, hey, look, I don't know what you had going on with this plan, but if you're just reading files, obviously you're not making a change. Why are we just reading files? That doesn't make sense, right? So the AI made the mistake. So we prompt it, say, hey, you made a mistake, you need to fix this, present a new plan. It doesn't have to go through the entire process again. It's going to review the existing plan with your feedback and then produce a new one. So, much simpler process. It's already done the hard work earlier. Now it can reutilize all those resources it's already gathered, produce a better plan based with your feedback. Once you have a plan that you understand and are okay with, you can hit approve. Even if you didn't have a plan that you fully understood, you could approve. The benefit to this application is if at the end of the day you look at what's produced and it doesn't work, simply type the \reject command into the chat, hit enter, done. That code is gone. You can reprompt starting over and work with the agent till you get something that works, and then you can approve it. Once you approve, after you've first you approve the plan, it starts doing the implementation steps. Once that's done, then you would do the approve or the reject. I mean, at any point you can do the approve or reject. At this point, once you start the planning phase, you can stop the agent from working. You can approve or reject the approve and reject what it's actually doing. Approve is going to merge the current Git branch that you're on. Reject is going to reject the it's going to switch you back to your main branch, and it's going to delete the branch you were pushed to as soon as you started the planning phase. The reason that as soon as you initiate a planning phase that it creates a branch is I have noticed there are a few agents that get kind of creative, even though I have tool restrictions on, that have gotten creative and tried to use tools and kind of gotten around the harness in different ways to start modifying files during the planning process, even though there's no... And I think that I've eliminated all of that. However, Still like the idea, if that does happen, that you're already on a different branch. So if for some reason you're using a model that just starts doing stuff and you're like, what the heck? Like, that's not even what's supposed to be happening right now. Simply hit your stop button, hit reject, open a new session with the little plus button, and start over. No harm, no foul. Nothing was overwritten that can't be recovered. Also, when you're in a branch, even if the LLM decided to delete the entire code base, you reject it, move back to the old branch, nothing's lost. The LLM also does not have the ability to delete anything outside of your repo. If it wants to run any commands that through bash that are unrelated to the directory in your repo, it will automatically pause and ask you if you will give it permission. If it is working inside of your repo, you're not bothered. The LLM's commands are just allowed to go through. And the reason why is because we're on another branch. I feel like some other tools like Claude and ChatGPT just really annoyed me with asking permission to use tools constantly. You know, simple tools like, oh, I want to run PyTest, or I want to cat this file that's inside the repo. Like, why? You don't need permission for that. Like, you don't need to bother me. I'm over doing some other research. I'm watching a YouTube video. I'm playing Halo, whatever. I don't know. Whatever you're doing. There's no reason the user should be bothered to have to interact with the LLM for every single permission ever, and then have to store some giant folder of, I've approved this before, let's approve it again, let's not approve this one, let's decline that one, because as soon as you deny it one time, it may not ask ever again, and then it starts trying to find fishy ways around, and that whole idea just seems ridiculous to me. I feel like the only reason the user should be bothered once you're on a separate branch, and we've already established that second branch as soon as the LLM has any ability whatsoever to edit things. The initial request model in chat only has the ability to grep, read. It doesn't have any MCP tools to do anything else. It's just able to explore. Can't make changes. So in that phase, we're perfectly fine. As soon as we enter plan phase, there are some tool swaps that happen between the different phases, and there's some risk there. Not much, but there is some risk. So as soon as that's initiated, immediately a branch is created. It also makes cleanup a little easier once you've approved or rejected a plan that's, either been implemented, or you just didn't like the plan and you just wanted to get rid of that branch and start over. So I've really tried to think through how this harness works, even though it's kind of slow. I feel like if you really had a powerhouse machine and you were using Llama CPP and you understood. Okay, so now we're editing tests, we're editing docs. We are, okay, good. Now we actually have there we go. There we go. Now it produced a proper plan revision after it had the feedback, and now it has our edit tool, edit files commands, to actually update these files. Perfect. So let's approve that. There's nothing in this that's going to get harmed. Okay. So now the reason it produced JSON and the plan kind of looks fishy, and the reason it produces this reason, that reason is used by us and by the LLM, to the implementation LLM, which is going to be your primary LLM, to understand what even though it knows what it's being told to do, helps it understand why it's doing it. I've found that if you just provide an LLM a rule, a direction, if you just give it a command, do this, not all of them are good at following that. In fact, I would say almost none of them are good at that, right? If it doesn't have a clear reason of why it's been told to do something, it just falls apart. It feels, I guess, unclear to how they've trained the LLMs in that whole thinking mode. I think without providing a reason with the action, the LLM is unable to actually produce a result. So the reason is there for twofold. One, it gives the human, us, the ability to understand why it's performing that action. It also provides a solid reason for the LLM to understand why it's performing that action. Not that it needs to decide to understand why it's performing an action, because it doesn't really have that ability. But if you give it a reason, that thinking mode that it has now, which again, I'm not an AI engineer, I don't fully understand. I conceptually understand how the thinking works. There's a whole lot of math behind it that I don't fully understand how it works. But conceptually, as a person, it's basically the who, why, what, where, when type thing. I'm sure that I wish I could pull up an article real quick that helps with this. Okay, so this is the other feature of the application. Obviously, we provided feedback, right? That feedback was that it only provided read file, and it should have provided edit file because it wasn't actually doing any work. Yes, I want to save that memory. Saving that memory is part of the... is that going to mess it up? No. So if I go into my memories here, these are all issues that the LLM has had over time working on this code base. And so over time, as it makes mistakes and you correct it, those mistakes begin to compound, and then they can be used for fine-tuning later, and they can be used during the planning phase. These get re-injected to try to prevent the LLM from making the same mistake twice, right? So this again is a part of the harness. As you're working with the LLM, it's immediately going to, every time you're working with it, if you're providing it feedback and you say, hey, you made this mistake, this is what you should have done, or hey, you're making a mistake right now, you need to be doing this, it's analyzing it every session, saying, hey, I see that when I did this, you sent me this feedback, and it reviews, the LLM reviews what it produced, your feedback, and then creates a memory saying, oh, okay, so I did this, you suggest I do this. Okay, so I need to be doing what you suggested, and I see what I did before. So let's create a quick memory of what happened, when it happened, so that I can not do this again. I think this is a super important feature that that is required when you're working with an LLM, right? Especially when you don't necessarily have the resources to fine-tune it yourself. If you don't have 8 GPUs or 4 GPUs to start fine-tuning your own LLM, this is the next best thing. Now, if you do happen to have all that GPU horsepower, this memory section is specifically saved in a format that allows you to then export this data and use a sister module that I also designed called Lean AI Serve. Lean AI Serve? Yes. Which can be used to take this data and then fine-tune your models. So if you're using this as a business because you have business requirements where you can't let your proprietary software or your or potentially user data to escape your system to get to ChatGPT or Claude or whoever, you can use a local model. As the model makes mistakes, those memories will be recorded. Those memories then can be used to fine-tune those models. So then you end up with a custom in-house model that is trained to understand and work within the bounds of your code base and your best practices and your engineers' expectations. So, and that would work with, the great thing about that is if you're a business, you would collect the memories from all of your engineers' machines, bring it into Lean AI Serve, and then fine-tune the model based on all of the feedback from all of your engineers, which then provides a much more solid fine-tuning than just one engineer. If you're just working on your own, having these memories and being able to have the LLM be corrected and nudged based on these memories and context that's being input is really nice, because at least even though you don't have fine-tuning, this is still a way to reduce your headaches, because now you have a way to correct the model and not have to constantly keep correcting the model the exact same way, because that's frustrating, it's annoying, it's a waste of your time. This is already kind of a much slower system than ChatGPT or Claude. The other benefit to this system, beyond the memories, which is really cool, is if you also are a business, you can use a local model for doing the code edits and doing the code exploration. Then you can use a proprietary Anthropic, Gemini, OpenAI, whoever you want to use, right, to actually do the more thought-intensive processes, such as generating the testing documentation, generating the actual planning steps. And what will happen is the proprietary model is only going to receive the markdown file that's generated during the planning process. And anytime the LLM, local LLM, picked up maybe a piece of PII or some in-house context that you want to have blocked, you can do that through the extension. And in a corporate setting, you can do this easier as well. You could design a YAML file. There's a whole in the GitHub, or a configuration file that can be distributed to all of your developer systems, right? Which is probably what you would do in a corporate environment. And within that, there's a refiner, task refiner prompt, privacy strip prompt. There we go. So in this privacy stripped prompt here, let's get rid of that for a second. So within this privacy stripped prompt, you can define what the LLM is looking for as far as sensitive data, and then you can redact that. What I mean by redact is literally it will send, if it finds a database connection string, it will replace that literally with a less than and greater than symbol, and it just says DB connection, which is plenty for Anthropic or for ChatGPT to say, oh, okay, all right, so this is a database connection string. Okay, I don't need the database connection string. I just need to understand that it is a database connection string here to provide a plan, right? It doesn't need to see the actual database connection string, so it keeps your credentials safe. The other benefit of having this on individual machine is you can create a corporate configuration for this prompt and distribute it to all of your engineers' setups of Lean AI, so it will run locally on their machine, automatically doing this refinement step before anything ever goes through Lean AI serve. And if you're using Lean AI serve as well, things will be refined on the individual application developer's system. And then when you're using Lean AI serve for more aggressive or larger models or whatever, then you can have your corporate policies also defined there as well for refinement. So then that strip process gets a second look, right? So it's again reviewing everything that's produced by that debug file, right? From phases 1, 2, and 3. Phases 1 and 2. All of that data is then going to go through that refinement process, or privacy strip prompt process for the LLM, then be sent to whoever, Anthropic, ChatGPT, whoever you decide to use. If you're using Lean AI Serve, you get an extra round of that. It's going to go through that process a second time and then go to ChatGPT, Claude, whoever, and then Claude can respond with its plan at the end of the day, which is just producing a simple text response and a JSON format for your local model to actually do the execution. You don't, if the plan is solid enough, you don't need a giant model to just quickly spit out code that has already been clearly defined if you make the steps small enough, right? Yeah, so also this saves businesses potentially millions of dollars, right? Now you're sending a very simple, already sketched out process of what you want changed and the files involved over to ChatGPT or Claude, which means they didn't have to do all those calls. It didn't have to read through all of that context. You're not using as many tokens, which means you save money at the end of the day. So it's saving money. It's helping you build a in-house refined model that will do the work you want it to do for your business. And it's really cool for kids that want to get into this, and learn coding. Because when I was learning, just viewing source was okay. But boy, if I'd had a model like this, I would have been over the moon. So then you can approve your plan. Your plan starts getting implemented by the primary model, starts working through all of these steps. You can keep track of what step you're on. This auto scrolls as it goes through the different steps. The expert model will always design the actual testing step. So if you're using Anthropic or ChatGPT or Codex, Codex or Anthropic will actually design the tests. And if for some reason your local model designs the code, writes the code based on the plan, and that code is not passing the test, especially if you have test-driven development, which I recommend, enabled, there's a whole extra phase that happens in there where during testing, if the code is constantly failing that the local model wrote through the testing phase, it can communicate with Anthropic or your expert model, whatever you have set for the expert, and say, hey, I think that your test was written wrong, right? Like, here's where it's failing, and the code should be working here, but the test just isn't designed properly to actually work with this code. And maybe that's because whoever didn't receive the proper context or whatever. So then there could be a debate between the two models, a back and forth of here's what I think is happening between the implementation model, or the primary model that actually wrote the code, and then the expert model that said, I wrote all the tests. Like, I wrote these tests solid. I don't know why you're complaining about this. Try again. Like, the tests are solid. The real problem is the code implementation. And then it can go through and have this debate back and forth. And if it gets too aggressive and the implementation model is not able to implement the code to pass the tests, at a certain point, the expert model will take over, will review the code and the test, and make a final determination of, is the code wrong or is the test wrong, and make an update to whichever needs to be updated. So at the end of the day, you'll always end up with a code base that's implemented that is passing all of the tests. I cannot say guaranteed a code base that is perfectly implemented and passing all of the tests and going to function in the manner you expect. There are going to be hiccups. It's not going to be perfect. But having all of these checks and balances in place to function more directly as a assistant in programming, this is the best system I could come up with. To harden it even further, if you are an application developer, there are extra things like notes. If you're ideating, or even if you're just a regular user, if you're ideating or just having a chat with your LLM and you're like, oh man, I had a brilliant idea, I don't want to forget it, right? You can ask the request model to make a note for you. And that note, you don't have to be super specific on it. You just have to say, hey, I'd like you to make a note based on what we were just talking about, right? And the LLM will immediately create a note, and then it will take and organize that note based on the project you're working on, right? And not only will it do that, but it will also create some of these notes were created by me for testing. Sorry, let me actually find one that was designed by the LLM. Yeah. Okay. So when you ask the LLM to design a note and then organize it into to take a note, that note automatically is organized by project. The note is taken, and then it's categorized by policy, documentation, improvement, and the LLM attempts to define to-dos, or next actions that need to be taken for every note that you create. The benefit to this is it saves you so much time, right? You could be in the middle of having a conversation with the LLM, like, oh, okay, this is a great idea. However, I want to put some more thought into this. So it's almost like put a pin in it, right? You're like, okay, take a note on this, and let's come back to this, right? Or maybe you're having a chat with the LLM, and it's like, hey, I can implement this thing for you, but if you really wanted to make this better, I think that this would give you a 10% improvement by adding this extra feature over here that's going to either be better for your users, or it's going to be better for managing this whole process. And so you could say, oh, I think that's a good idea, but that's currently not in scope for what we're trying to do right now. First, let's go ahead and tackle and bite off this piece that we're already in the middle of. Go ahead and make a note about that other thing. It'll create this note. It'll provide as much detail as it can, so that you can feed it back into the LLM later if you'd like, and also create a to-do list for you if you want to manually do the work, or if you want to manually explore what's left, right? So this is just a kind of cool extra tool that helps you keep track of things that you are currently working on in your projects. Then if we go, so that's our notes. There's our prompts. If for some reason you find that my system is not producing what you would like to see from the LLM, you have full control. Nothing's hidden here. Every prompt that is fed in through the system from the Python harness into the LLM at every step of the way is stored in a prompt registry.py. However, some people are not going to want to review the prompt registry.py because, you know, it's work to actually have to read through. Not to mention, to be honest, it's like a 3,000 line file. So instead of doing that, you can come in here, narrow down what prompt you're looking for, find the prompt, and do some automatic updates and adjustments yourself. There are warnings and cautions, and it explains what to be careful of updating because you may break the entire chain of events if you remove certain things. Those certain things, and it explains that, are generally these things that are within the confined brackets because that is replaced by Python. So if you get rid of those, then the next chain of events can't happen. Because Python will receive a request from the LLM and will have no way to actually send over a reliable answer over to the next model. So yeah, nothing's hidden in this project. It's also open source, and all of the settings are easy to be modified by the users. If you like vibe coding, or you just like the idea of having a LLM chat with you, you can turn on text-to-speech and speech-to-text, and you get a little microphone here, and the LLM will use Kokoro for text-to-speech, and whisper, faster whisper, I think, for no, faster whisper is for speech to text. Kokoro, and I'm probably saying it wrong, is used for the text to speech. And then if you like that thing, and you could choose, you know, what voice you want. There are also voice options here. I wouldn't set them here unless you've found the one in the option that you really. This is basically just your default that will automatically come up selected here. And then you can default speed, right, number of threads you want for your CPU, and you can also have a wake word like "Hey computer" if you wanted. Then there's UI verification. Again, not a feature that I see in a lot of harnesses, right? During testing, you can have the LLM as one of its testing features if you're working in a, let's say you're designing a Python video game, or you're like with Pygame, or you're designing a web application, and you ask the LLM to write tests, right? It can do a pretty solid job of expected input, expected output. It can write those tests pretty solid. However, being able to actually review expected input, expected output through a web browser is not something that's generally offered to an LLM. So I've also added that feature in here. So during testing, you can actually have it do a verify web UI or verify desktop UI tools. Now there are some extra things that need to be installed. I tried to make it easy as possible to install those. There are some options here to automatically run those. You can run a test capture if you would like. I'm not going to run those right now. Maybe I should. I don't know. Sure. Example.com. Sure. Whatever. Default. Oh, yeah. Okay. So I do not currently have that installed, so I'll have to go through and do the whole installation. It's described in the configuration. anyways, if you want to do UI testing, you can have that enabled, and then that just gives your LLM more feedback and better testing than just input in, output out. Does this look right? Did anything break? I mean, technically, probably nothing broke, right? As long as the input and output are what's expected. But there are lots of things that could break in the UI. Unexpected things that happen when you click a button or a link or a card or drag a card or move a button or whatever the case may be, especially in web applications and video games. This just gives it a way to snap some screenshots, again, go through that whole quadrant, UI verification of that screenshot, and it doesn't require your interaction. It's just one more testing layer that allows the UI to try to provide, I think, what everybody wants based on what I'm seeing online, which is the one shot and we're done. My goal here is to still allow that ability, but let's allow it in an engineering perspective where if you one shot and you YOLO, that one shot and YOLO is not going to be a mess for someone else to either clean up, or is not going to cost you millions of dollars later because you leaked thousands of people's information or whatever, right? The whole point is, if you give the LLM better context, you're going to get better results, right? If you provide it a strong harness and all of those harness pieces are solid, which I think they are, but I need your help testing it, you're going to get a better result at the end of the day, right? So, oh wait, is it done? Yeah, okay. So every time it finishes a plan, the one thing that sucks on this application's, on this project specifically, right? This project is over 4 gigabytes in size. Hold on, let me verify so that you guys can see that I'm not lying. Oh, I cleaned it up a bit. Okay, I'm sorry. Yeah, I had a bunch of leftover JetBrains builds and extension VSIX extension builds. I cleaned that up. Okay, so anyways, so the project size is 1.4 gigabytes, right? That's a lot for a local LLM with 128 kilobyte, or I'm sorry, 128K token context window, right? So at the end of each implementation phase, it automatically updates the project context. This just keeps that project context up to date with every change you make. So then if you ask it to fix something based on the change that just happened, it can look at the project context and be like, oh yeah, I have a reasonable understanding of what just changed. Obviously, there are other ways you could do this, right? You could use a bunch of tools, like Git version history, Git diffs, to have the LLM start analyzing the actual code changes that you made. Those tools are available here, but I feel like they're a fallback, right? You don't want them to be the primary research vector for requests like that, because it's data overload, right? I mean, you may have had to modify 26 files to implement a new feature, right? So now you've got a 26 file diff that your LLM with 128K token context window is trying to review, that's 1,500 lines long, right? I mean, can it do it? Sure. Is it going to remember all of it? No. It's going to have the lost in the middle problem. It's going to forget that the primary culprit of what you're asking it to fix is the file right in the middle of all of that GIF diff it just looked at. I just don't find, like, the Git diff is useful to have. It can shed light, but the project context really needs to be the source of truth, right? To give the LLM a starting point, and then allow it to actually start looking at those files that are involved with those calls. And yes, that's some re-exploration, and yes, it could just look at the Git diff, and potentially, and if you use the Git diff tool properly, you can just look at the individual file. And you're right. If you've ever tried to use the local model and do that, let me know that you've pulled it off successfully, and that bash command is always firing accurately. I'll implement it. I have not been able to get an LLM to reliably not just grab the entire Git diff. It's going to grab the entire Git diff, not look at the individual file that changed in there. It's just going to keep grabbing that whole thing, all 1,500 lines over the 26 files or whatever it is, and then it's going to get lost, and it's going to be like, I don't see target file. I don't think it was touched. It says in the project context it was touched, but I'm not even going to look anymore. Like, I keep getting confused, and it's just going to keep reading it, and still not able to see that middle piece. Fill the context window, do a context refresh, and that's a whole nother ball of management that's inside the system that does I would say, a amicable job of managing that scary process, but it is not perfect. I don't think there is a perfect solution currently with context windows. I mean, the perfect solution is to just find a better management tool than the KV cache. I mean, that system, I don't know that there's a better solution. But, I think because we got stuck with KV cache and how that works with Llama CPP's implementation, and everybody got on board, it would be nice to see something different. Other than TurboQuant, I feel like the future is going to be 1-bit models eventually. Apparently Microsoft is on top of that future, which is really cool. And is the other one Bamboo something? It's not Bamboo Labs. There's another lab that's also released a 1-bit model that's really cool. I think 1-bit models would be the future, and then I think if we can move away from KV cache to something different. I don't know what that something different is. I think local models will win the day. Just saying. Or if you don't have a gaming PC, the other benefit to that is, even if local models don't win the day, and you still want to use a 1 trillion token model, right? You could do that with a 1-bit model provided by somebody like an Anthropic or a Chat OpenAI, right? And if they had both the ability to have a 1-bit model that's providing just as good answers as a 16-bit, and had a different type of KV cache that worked better, where it could be expanded reliably to 5 million token context window, whatever the case ends up being, but with the footprint of, let's say, 32 gigabytes of VRAM, holy cow, or let's even say 120 gigabytes of VRAM, with a 1 million context window and a trillion token model, it would still allow them, especially OpenAI, to keep that $20 price and just put everything in that $20 price, right? They wouldn't need to charge $100 or the $200 for codecs, because they could easily pay for that inference with your $20 a month plan. So not only would it allow for greater scaling, it would also allow for better local systems for businesses that require local systems, or governments that would like to implement AI in specific guarded systems, and have that AI air gapped and still be reliable, smart, and able to perform specific functions the same way every time. So, anyways, I don't even know how we got here, but the updating project context takes a while on a 1.4 gigabyte project. So, I gotta give this a minute. It always takes a while on this project. Once the project context updates, then you can approve and move on to whatever the next thing is that you want it to do, or you can reject it. It's up to you. If this is a web app, I would just open it in your browser, check that everything's working properly, and then decide whether or not you want to approve or reject. In this case, I know exactly what's been changed. I know exactly what files have been changed. I know exactly what lines have been changed. I'm not concerned that it did anything wrong here. And also a summary document will be produced as soon as this context is finished being updated. Also, the other cool thing is, I was talking about memories and sessions, especially for business. If you've ever been in a situation where you're you're in a business and you need some sort of auditing trail for what your developers are sending through in each session to your chatbots and what the results are. Red have been rejected, green have been approved, blue have been approved and merged. Green are active sessions and can either be resumed or discarded, right? Red I've dumped that branch. I've deleted the branch, sometimes manually, sometimes through the reject command. Unfortunately, I have a bad habit of not running the reject command always, and then I'll just open a new window and start doing something, and I'm like, oh no, forgot to delete that branch. The good news is, if that happens to you, whenever you start talking with the LLM and you ask it to do something, it's always going to pull from the main branch to create a new branch. It will not pull from, if you're in a branch, it will not pull from that branch to create a new branch. So you're always pulling from main, which can be seen in two ways, right? It can be a problem or it's a solution. It just depends on how you look at it. In my opinion, I like the idea that it's always pulling for main, because sometimes I just get annoyed and I just close the application and I just don't care to, I just start a new session, start doing what I need to do, and I don't care about that at all. And then I'll just randomly go through and do a get branch review, and I just start paring everything down. Since I know how to do the get commands, if you're a normal user and you don't know how to do that, I recommend waiting and approving or rejecting. If you have a smaller code base or a web application that's updating project context, it's going to be done in 3 minutes or 2 minutes. It's going to happen very quickly. Once you start getting into the gigabyte size projects, it starts, it's going to be slower. 128K context window is not that big. I think I've been through everything this application does, how it works. Oh, no, I forgot a very important thing. Again, based on the sessions down here, if you're in one of those situations, you get a call at 4 a.m. Hey, production's broke, and you're using this system, and you've worked with the AI. Even if the AI didn't implement the change, every time you start a new chat, it starts it as a session. You can then go back and review that conversation history with the LLM. So if you made some change 6 months ago and there's a single client that's complaining they're not getting their data, but everybody else is getting their data because there's some weird edge case that happened before you ever even started at the company that was originally coded in and you accidentally fixed during your change because it was non-standard and you didn't know why it was there. You can search your past conversations for any kind of research you did with the LLM about the code base, which might help you understand what you were thinking when you made that change. Or if the LLM implemented it, you can do a search for what was changed, and then you can pull up the entire history of that session and scroll through it like we are here. Look through the whole thing, figure out what you asked it to do, what the plan was, what you approved, what you didn't pay attention to. All of it's logged. So, also gives you the ability to show it to your boss. Like, it didn't say it touched that file. I don't know how it touched that file. That's kind of on you, though, too. I mean, because at the very end of this, after it finishes updating the project context, it's going to present me with a summary. And one of the things is a very clear list with a clickable link that you can click and then view the diff for every single file. So if you didn't at least go through those, then you're not doing a very good programming job. Like, unless it's a diff that's like 2,000 lines long. But if you have a diff that's 2,000 lines long and you made it with a local LLM in one shot, I'd like to know what in the world feature you were adding. And why did it require 2,000 lines? This ain't ChatGPT or Claude Code. We're not spamming code out here. We're trying to be. Oh, what is that thing that they always say? The ladies are always say. Is TikTok famous for a minute? So polite, so demure. That's what we're going for with this app. Polite and demure. We're not going for I wrote more codes than Claude Code today with a local LLM. No. We're going for surgical precision edits or specific functionality being added as a single file that can be called and reused by other code, right? We're not looking for token maxing here. We're looking for, I want to get this done as quickly as possible, and I want to get this done with the minimum code. So let's go through all these planning steps and let's do it like a real programmer would to help create the same environment a real programmer would be in and try to get a more precise result. Also, to be fair, this smaller local model, it's required if you want to actually produce something that isn't garbage. If you don't do this, you're gonna get hit and miss. You might get a snake game, but you don't get your high score table. You might get a ping pong? No. What is that called? The Atari game with the paddles that go up and down. Anyways, you might get that game, but again, the ball might go off screen and the game never hits the end, right? Like, it seems like the local LLMs can get you, I don't know, 60% of the way there. By that I mean based on you providing very minimal input. So, I don't know. I hope this helped. I hope if you'd like to check out Lean AI that you do so. And I hope you have fun with it. And I hope you break the crap out of it. And I hope you file 8,000 issues for me to fix. I hope I don't get to sleep for the next 6 months. I hope I get so inundated with issues that, yeah, I don't get to sleep for a month. And I will stream, if that happens, I will stream fixing every single one of those issues. And I might even allow the snake to eat its own tail, because the next part of this system that I'd like to add after I get this a little more stable, you remember the Notes app that we saw? Wouldn't it be cool if overnight it could review those notes, turn them into plans? If there's enough context in your system, right? And you have a well structured and defined application already, it'll probably be able to go ahead and define those into plans. It'll at least attempt to make a plan for each one. But if it's actually able to successfully create a plan without needing clarification, it just went ahead, created a branch, and implemented each of those notes, and then you could come back the next morning and be like, oh, your tasks are done. Let's review those tasks and see if they're right. I mean, I think that's kind of really where something like this could shine, is you go home at the end of the day, you leave the system up, you let it continue working on those tasks that you've had set aside, and if your code base is well defined enough, it should be able to, and based on your note, should be able to go through, pick up, take off, and overnight just keep ticking away through those tickets. And then you can review it and then determine whether or not it's acceptable. If so, approve it, move on, right? The goal is to automate as much as possible. If we get to the point to where we're really trusting the system, we've got enough memories in there, enough feedback, we fine-tune the model if you're a business, now you're ready to go. Now you can approve, move on, let the system go based on the tasks that you have defined. Hit your goals, don't worry about it, right? Now you're at the YOLO stage. You've done the hard work of using the tool, creating the memories, most of them bad, and then taking those and using them to fine-train the model, and then fine-training the model towards your code, and then then you can get to the point to where you trust it, right? And it's your own in-house model that you've trained yourself, so you fine-tuned yourself. Sorry, you didn't train it yourself. So you can trust that it's not going to do anything that it hasn't really done before, unless something weird happens, like the VRAM in one of your GPUs gets corrupted or something because somebody's running by with a magnet. I don't know what happens then. I mean, hopefully your server just crashes for a second, reboots, and then you're okay. But if not, I'm not responsible for hardware issues. Sorry. All right. Well, anyone that wants to use local AI, maybe this is the answer for you. All right. My name's Alex, and thank you for watching this.